Hello, dear students. Welcome back again to study physics. Guys, today lesson we have some example to solve calculation, some of them. So before to start to explain, there is some rules should be memorized. Important that rule, guys. You have some rule. First rule, it's written to find the molar mass, sorry, the molar volume. Molar volume, it's written or it's called by Vm, it's molar volume, V capital M small. Vm, this is the rule, Vm is equal to M capital M small over P. This M capital M small, that one is molar mass, it's called molar mass. And P and or rho, you know, is density. So Vm, molar volume, equal to molar mass over density. This is the rule to find the molar volume in each equation. Rule number 2, to find the volume of one atom. So there is two rule of volume, do not mix it. First one is molar volume, but that one just to find the volume of one atom. V equal to Vm over Na. This Vm, we said now this, the first one is molar volume, and Na, it's called Avogadro number. Avogadro number, the number of Avogadro number is all time 6.02 times 10 power 23. This is Avogadro number. Rule number 3, to find the distance between two atoms. Guys, you have a distance between two atoms. Look, I want to find the distance between two atoms by this rule. If we have atom to atom, I would like to find this distance between atoms is equal to what? By that rule, L equal to V inside meter cube. This is called meter cube. So find the volume of one atom and then put it in here. You can easily find the distance between two the atom. The last rule, to find the mass of one atom. Mass equal to molar mass over Avogadro number. That one is molar mass is Avogadro number. This one, look, M mass, and M capital M small is molar mass over Avogadro number. So there is, guys, just four rules. First, molar volume, and the mass, sorry, volume of one atom, and distance between the atom, and the mass of one atom. Okay, example, guys, look. Estimate the distance between two atoms. Estimate the distance between two atoms. It means what? Find L. Find L. I would like to find L. The distance between the distance between these two atoms equal to what? Find L. Which atom? Copper. If you know that it's molar mass, it's written M capital equal to 0.064 kilogram. Okay, and even density, the density, it's written to the density or P equal to 8,000 kilogram per meter cube. And even Avogadro number, it's written, look. Okay, so the question said find L. Guys, the rule to find the distance between the atom, it was L equal to V inside meter cube. We have to use this rule, but guys, let me tell you something. Check now in the question, do you have a volume immediately directly to put it in here and find the L distance? No. Look, do you have a volume? No, this is molar mass and this is density. No, we don't have a volume. So in that case, first go to find V and put it in this question, then find L. So what was the rule of V, just V alone? V equal to Vm over Na. Find V, then put it in here. But guys, we have another problem. We have Avogadro number, but we don't have Vm. Do you have a molar volume? No. So we have to go back to the first rule. Vm equal to molar mass over density. Guys, look, let me tell you the rule. First, use this rule. We have molar mass and you have density. Find Vm. When you get the value of Vm, put it in here. You can get the value of V. When you get the value of V, put the value of V in this equation, and you can easily find the value of L. So step by step. Okay, Vm equal to, we have a density, and density is equal to 8,000. And the molar mass, you have 0.064 and kilogram. Sorry, and that one is kilogram over meter cube. So the kilogram together gonna be cancelled. Meter power cube is left, and divide this by calculator. 0.064 divided by 8,000. The answer is, I think it's 8 times 10 power negative 6. The answer to find Vm, guys. So we have already found Vm. So now put this answer in that question. Go to find V. Yeah, V equal to this is the rule. Look, Vm. We got the value of Vm. It's 8 times 10 power negative 6 over Avogadro number. So the Avogadro number is 6.02 times 10 power 23. Use calculator. Divide that number. The answer is 1.33 times 10 power negative 29. Let me fix it. Negative 29. Okay. Times 10 power. Why it's like that? 1.33. 1.33 times 10 power negative 29. Okay. The answer is 1.33 times 10 power negative 29, and the unit, because this the Vm is by meter power 3, and the Avogadro number is just mole, so the answer is still by 1.33 times 10 power negative 29 meter power 3. The last rule now, because even we've got V, now put the value of V in here, and you can easily find the distance between the atom. L equal to meter cube, it's power 3, the number put in here 1.33, and times 10 power negative 29. So do the calculator. The answer is 2.37 times 10 power negative 10. The last answer, it's 2. The answer it's 2. The answer is there is no place. The answer is 2.37 times 10 power negative 10 meter, because there's a distance. Okay, guys, we have some examples in the same page. Question 1. The equilibrium distance between two neighboring atoms is given element is 1.2 times 10 power negative 10. Guys, equilibrium distance. So that means it's R naught. So R naught equal to 1.2 times 10 power negative 10 meter. So this is called R naught. R naught is equal to 1.2 times 10 power negative 10. Would the interatom force be attractive or repulsive? We want to know if the type of the force that we have between the molecules, is it attractive force or is it repulsive force, or there is no force? How we know that? Okay, guys, look, Baba. Part A, the distance, you have 1 times 10 power and negative 10. As I told you, we studied 3 parts. If the distance is smaller than compared to the original one, if it's smaller, type is repulsive. If the distance that you have compared to the original, if it's great, if attraction. If they are same, there is no force. So look, this distance R Guys, because they have same power, no, do not count the power, just count the number 1 and the 1.2. This distance r, it's 1. Compared to the original, we have 1.2. It's smaller than r naught. Because you have 1 and 1, it's smaller than 1.2. So this r, it's smaller than original 1. So the type is repulsion. Repulsion force. Why repulsion force? Because the distance is compared to the original 1.2, it's smaller one. Part B, we have 1.4 times 10 power negative 10. This R. Again, compared to the original one. This R is 1.4. Is it small or greater as 1? Look, it's clear, guys. You have 1.4, but this is 1.2. So the 1.4 is bigger than 1.2. This R now is bigger than R original one. So the type of the force now we have it's attraction. Attraction type. Attraction force, because this R now look is bigger than the because you have 1.4 is greater than the original one, but in the first case you have 1 and 1 it's smaller than 1.2. That's why attraction. Okay. Question number 2, guys. Question number 2. What are the 3 types of bonds among atoms? Are these bonds due to electric force or due to gravitational attraction? Question number 2. Question number 2. What are the 3 types of the bond? We know the 3 types of the bond we studied. First one. The first one is ionic bond. The second one, covalent bond. And the last one, metallic bond. So these type of the bond, due to electric force, or they are combined, their form type of the force is formed due to electric force or gravitational force. Guys, even by the definition of the bond we studied, we said the bond that is formed between 2 negative and positive charge, right? Even I showed you the picture. Between negative and positive charge, we have a bond between negative and positive charge. Look, it's negative and positive charge is electric, of course electric. So this all the type of the bonds is due to electric force, because guys, between the molecules, the bonds are formed between 2 atoms by negative and positive charge. So negative force, of course, it's electric. Okay. Question number 1, section review. Does matter change from one phase into another due to exchange of mass, charge, or energy? Justify your answer. And guys, we studied if we have a solid state of the matter, for example, solid. To make a solid to liquid, you have to give them heat, thermal or mechanic, to make it liquid, then liquid to make it liquid, then liquid to gas. So during when you have to during when we want to convert the state of the matter from solid to liquid to gas by give them energy. So during when this process happen, it's when the matter change from one phase into another is due to changing of mass or charge or energy. Guys, of course, according to the energy or due to energy, because the mass of charge will not be changed even, just energy. When you want to change the state of the matter, the solid to liquid, of course the energy it will be changed too, because solid they have energy and liquid they have energy and gas they have energy. They have like different energy than each other. So we have 2 type of energy. You start in grade 9, 2 type of energy. We have kinetic energy and with potential energy. Kinetic energy with potential energy. So both of them will be changed when you want to change the state of the matter. Both of them, matter change from one phase into another phase through their kinetic energy, their kinetic energy, kinetic energy and potential potential energy. So the kinetic energy and potential energy matter change from one phase to another phase according to both energy, kinetic energy and potential energy. Question number 2. A repulsion between atoms at very close distance due to interaction between. Guys, look at that question. Important, this question. Repulsion between atoms at very close distance. You have two atoms. I would like to make it so close. These two atoms. When we know it's repulsion happening because we say the distance is small. Is due to repulsion between atoms at very close distance is due to interaction between their electrons close. Is this repulsion due to fact that, guys, we know when two atoms gonna be close, it will be repulsion. But this repulsion is due to fact that, because there isn't that the electrons, they are very small, or to their charge or to their mass. We know that because their distance is gonna be so small that why the repulsion it will happen. But why, even the distance is small, why repulsion will happen between to the molecules? Guys, let me make it a big picture. Look, as we know that with this atom, around the atom we have electron, right? When you want to make close these two atoms together, when you like to make it close to get this atom, we know that at distance it's small, it's going to be repulsed. But because these two atoms, they have electron around the atom, spinning electron. This electron, they have a negative sign. Both of them, they have a negative sign. When you like to make it close, a negative with negative, because same sign, they are repulsed together. Look, negative sign with negative sign, they like to get away because same sign. They go away together because same sign, negative. Even if it's positive too. In physics, just if you have a different sign, negative and positive, it will be attracted together. But because when you like to make a close two atom together, because each atom they have electron, and this electron they have a sign, same sign, negative and negative, same sign, they cannot to get so close because they have same sign, negative and negative. Directly, it's gonna be a repulsion because same sign. They're like even two comes next to each other because they have a same sign. So the answer is by, let me write the answer. The answer, because in fact is that because there is this repulsion force interaction between the same charge of the electron, because same charge of electron, they have a negative electron, and because they have the same charge, that's why a repulsion will be happen. Not because of the mass and not because of the electron very small. No, because of the charge, the sign is negative. Okay. Guys, question 3. Comments on the fourth distance curve between. Question 3, actually in book we have a graph, but we don't need the graph. Without the graph, we can immediately directly get the answer. Guys, this question is still the same. You have 3 parts, A and B and C. Important, so this question. Write the type of the force. Comment on the force distance. Just write the type. First one, look, the first one, we have A, R equal to R naught, or close, it's approximate, is close to each other, or we can say equal, R equal to R naught. Here we said if both of the distance equal, so the type of the force, is equilibrium state, or there is no force. Equilibrium state. Okay. Part B, the R is turned to 0, or R becomes 0. R becomes 0, that means the R distance is gonna be 0. So this R becomes so small than the original value because there is no distance, it's 0. So that means R is smaller to the original one. It means that repulsion type force. repulsion force, because R is smaller than R naught, or equilibrium distance. The last one, R turns to infinity. Infinity, it means a large number. So that means the R value, the value of the R is so large. So this R is bigger than the R naught. So that means the type is attraction type of the force. Important, guys, be careful that one. Last example, the molar mass of a sodium. Guys, this calculation, molar mass, we know the molar mass is M capital M small equal to 22.98 gram molar mass. What is the molar volume? Find Vm. If knowing that the density, you have a density, the density P equal 9.71 gram over centimeter cube. We don't know this temperature, it's not important. So find Vm. Guys, look, we have the rule in front of you. I wrote for you, look. We have to use which rule? We have a molar mass and you have a density. Just find Vm. Of course, the first rule. Look, first one, because we have molar mass and you have a density divided, we can find Vm. So Vm equal to molar mass over density equal. We know molar mass, it's written, it's 22.98 gram over density, it's 9.71 gram over centimeter cube. The gram is going to be cancelled. So divide both. The answer is, I think, 2.37, the answer, and centimeter cube. So the answer is 2.37 centimeter cube. Guys, today it's enough. We solved it, finished now. We solved all the example that we have in chapter 2, and I'm done. And I hope to understand, I hope to get a benefit from my video all time. Thank you for watching my video. Please subscribe to the channels immediately when I posted the video, to know that I published the new video. Thank you for all. Thank you again. Have a nice day.